The creation of any design requires careful thought about what it's going to be made from. If you use the wrong material, you are already limiting your design. For example, in biomedical engineering, there are 4 different criteria that have to be met. If the material used fails any of the criteria, it wouldn't be a viable health solution. An example in practice is the production of lightweight and strong prosthetic sockets, which are made using carbon fiber. Carbon fiber provides strength, however it's brittle as has a high Young's modulus. Therefore, for the prosthetic to actually function, it must be combined with other materials by a process called lamination. First, let's start with stress, which is easier to explain using the equation. As you can see, stress measures the internal force per unit cross-section area. So what does stress actually tell you? Well, it tells you the material's tensile strength, which is the level of stress at which a material will fracture, and it will also tell you the yield stress, aka the elastic limit, which is when the material will no longer return to its original shape. Now moving on to strain, which is caused by stress. The equation for strain is length now minus original length divided by original length. Using stress and strain, we can calculate Young's modulus, which measures the stiffness of a material, so how much a material will stretch when you apply a force. We can also plot stress against strain graphs, which for each material has a distinct shape. Using these graphs, we can calculate how tough the material is by calculating the area under the graph up to the fracture point. We can also see the elastic region, where the material will return to its original shape once the deforming force has been removed, the elastic limit, and the plastic region, where the rate of extension is increasing. Brittle materials such as glass have extremely short elastic regions and will fracture with no plastic region.